In this video, we're going to continue exploring hypothesis testing, and in this particular example, we're going to work with sample means. So we're going to learn how to conduct hypothesis tests using sample means. So we've seen this question before in a previous video where we calculated its 95% confidence interval, but this time we're going to do a hypothesis test. So a large accounting firm is trying to determine what fee to charge for next year's returns. In previous years, the actual mean cost of the firm for attending a client audit session was $650. To determine if this cost has changed, the firm randomly samples 32 client audit fees. The sample mean audit cost was $680 with a standard deviation of $75. And we have two questions here. So our question A is to perform the appropriate test to determine if the mean cost is now difference from the historical mean of $650, and we're told to use a 0.05 level of significance. And then finally, we're supposed to comment on how the confidence interval estimate supports the result of the hypothesis test. So I guess we will redo the confidence interval as well. So let's go ahead and dive into this question. So let's write down a few things that we're told. We're told that the mean audit cost, so X bar, was equal to $680. We're told that we have a standard deviation, so an SD, and this is of the sample mean. So SD X bar is equal to $75. And we're told that we have a sample size of 32. So N is equal to 32. We're then asked to perform an appropriate test. So we'll just do a hypothesis test here. So we'll create our hypotheses and then we'll do a t-test. So first, let's start with our null hypothesis. So our H naught. Well, in our H naught hypothesis, all we're going to say is that mu, or the mean of our population, is equal to $650, right? From the historical mean of $650. So our null hypothesis is that the mean is equal to the historical mean. Our alternative hypothesis, our HA, is simply going to say that the mean does not equal $650. It might be more, it might be less. We don't know. All we're saying is that our alternative hypothesis is that the mean does not equal $650. Make that a little bit bigger for you, just like that. Okay, so now we can go and do our t-test. So we're going to do t at n minus 1 degrees of freedom is equal to X bar, and we'll just say this is mu of our null hypothesis, X bar minus mu naught divided by the standard error of X bar. And where we said the standard error of X bar is equal to the standard deviation of X bar divided by the square root of our sample size. So what we're going to do here then is equal to t at 32 minus 1 degrees of freedom is equal to $680. That's the mean of our sample minus mu naught, which is $650. So $650 divided by $75 divided by the square root of 32. So then what we have is t at 31 degrees of freedom is equal to, well, 680 minus 650 is equal to $30 divided by the square root, divided by 75 divided by the square root of 32, which is, as we've calculated before, 13.2583, rounding to 4 decimal points. So 30 divided by 13.2583 gives us 2.2, And we'll keep it at 2 decimal points. So t at 31 degrees of freedom is equal to that value. So if we think about this conceptually, we'll just draw a little t, our t distribution. Going to look very similar to our normal distribution, centered around 0. What we've established is that we have a t-score here at 2.26. And we're told to use 0.05 level of significance. So what we're looking for is the critical value, the t critical, that gives us 0.025 in each tail. Since we're doing a two-sided test, right? Just does not equal, is equal to a two-sided test. So let's go ahead and look up our 95% confidence interval, our 95% confidence critical value at t at 31 degrees of freedom. So we'll go to our sheet here. We're looking for 2 tails. So we're looking for 2 tails of 0.05, 0.025 in each tail. We can also scroll to the bottom of our T chart and see our confidence level. Our confidence level being right here, 95% confidence level. So that's great. We're going to look up T at 31 degrees of freedom. Well, we don't see 31 degrees of freedom. And again, we can always interpolate to get that value, but usually we can just estimate. So T at 30 degrees of freedom is 2.042. So 2.042 is that critical value right there. So therefore, because .26 is greater than 2.042, we reject the null hypothesis in favor of the alternative. Right? So simply we're saying that our null hypothesis that the mean was equal to $650, we are rejecting that null hypothesis in favor of the alternative hypothesis that says the mean does not equal $650. Now we can just quickly do our confidence interval if we'd want. So we recall that our confidence interval is simply equal to our estimate plus or minus our margin of error. So in this case, our estimate was $680 plus or minus our T star, our critical value at n minus 1 degrees of freedom, times the standard error of x bar. So this is $680 plus or minus. Well, we've already calculated our critical T value at approximately n minus 1. So this value right here so 2.042 times the standard error of x bar, which we've already calculated in the previous part of the question, 13.2583. To give us our, so this becomes 680 plus or minus 2.042 times 13.2583 plus or minus 27.07. So 680 minus 27.07 gives us 652.93, and 680 plus 27.07 gives us 707.07. So what you'll notice about our 95% confidence interval here is that the estimate of 650, that was the historical mean of our audit fees, is not included in our confidence interval. So sometimes it's easier just to visualize this so that we can draw kind of just a rough number line here. So if our historical mean was $650, what we are saying effectively by this confidence interval right here is saying that we are 95% certain that our true estimate will be somewhere between 652.93 and 707.07. So it's going to be somewhere in this yellow shaded region. So because 650 is not included in our 95% confidence interval, this confirms our conclusion that we did by doing the t-test. Simply because 650 is not included in our 95% confidence interval, we still would reject the null hypothesis in favor of the alternative.
That's it for this video, but if you found that it helped to make statistics easy, consider showing your support by giving the video a like. And if you still need more help with statistics, then consider subscribing to the channel if you haven't already. I look forward to solving many more problems with you next time.